Hi everyone. In this video, I will walk you through how I deployed an AWS Gateway Load Balancer and used it to inspect the traffic coming from my application servers through a security appliance. We will cover the full workflow, including the gateway's load balancer setup, endpoint service creation, endpoint deployment, and routing. I have configured an open source security appliance for this demo, but you can use any third party or commercial appliance that supports GNV protocol. And in my next video, I will show the complete step-by-step configurations of security appliance itself. Let's begin with the gateway load balancer creation. Gateway load balancer, which acts as a traffic distribution layer in front of our security appliance fleet. Let's give name. For now, I'm selecting IPv4 address type since I did not create any IPv6 VPC. I'm going to select two subnets, which is going to be a public subnet. I have already created one target group. I'm selecting that. Let's create the load balancer. Meanwhile, the gateway load balancer create. I'll show you the subnets routings. I have added a 00 destination to IGW, and for this subnet it will take couple of minutes to get created. So now the gateway load balancer is active. In the target group, I have already added my security appliance, which is open source. Since I already mentioned that I'm going to use for this demo open source security appliance. So you can choose any security appliance that supports GNV, including Fortinet, Palo Alto, Checkpoint, Cisco, Suricata. As not, the gateway load balancer simply forwards a package to your appliances for inspection. So the vendor doesn't matter as long as it supports GNV or it has an agent that can process packets. In this demo, I'm focusing only on the gateway load balancer configurations. In my next video, I will walk you through a complete security appliance configuration, packet flow, GNV, routings, policy inspection, and forwarding. Since the gateway load balancer is active now, let's create endpoint service. Select load balancer type as a gateway. and select the IPv for protocol, IPv for address type. Let's wait. Now it is available. This service will be consumed by the gateway load balancer endpoints in your application VPC. Now let's create endpoints, gateway load balancer endpoints. Select endpoint service name here. Copy the name, service name from endpoint service which we configured earlier. Verify the service. Select the VPC where you have deployed gateway load balancer. Select the VPC where you have application server, whether it can be in a different VPC or in the same VPC. So I'm selecting here subnet. For gateway load balancer endpoint, I have created separate subnet. I'm creating now. I'll show you the. Let's accept the request first. Once you accept it, take a couple of minutes to be available. So each endpoint act as an entry point for application traffic to reach the gateway load balancer and then the security appliance. So we are going to update the route table with this endpoint for our each application subnet. Now the endpoints gateway load balancer endpoint is available. Then now let's go and update the route tables of application subnet. I have deployed my application. This subnet, let's verify once. This is my subnet. Yeah, correct. I'm going to add a route. Gateway load balancer. Endpoint. And now all internet bound traffic from these servers is redirected to gateway load balancer and then forwarded security appliance for the inspection. Here we have also required to create a separate route table for gateway load balancer endpoint subnet. And also we need to create one IGW edge route table. IGW edge route table is a routing layer on the edge of VPC, right where the internet gateway connects your VPC to the public internet. So it is like a small dedicated route table that controls how traffic entering and leaving the VPC through IGW is forwarded. And why is the edge IGW edge route table required for the gateway load balancer? When using gateway load balancer, AWS sometimes needs to send and return traffic back to the application server through the correct path. Here is the challenges. Traffic from your instance goes to gateway load balance endpoint, then to security appliance. Then security appliance sends the package back to sometimes towards the internet. For this return traffic, AWS must ensure the packet returns via same path. Traffic is sent towards the correct next hop. The connection remains stateful, and security appliance does not break flow symmetry. The edge route table helps AWS maintain this path consistency. That is why we required edge route table. Yes. What you need to do is simply edit this edge association and add the associate the IGW here, and the add routes of application subnets where you deploy your application server towards the VPC endpoint, go gateway load balancer endpoint. So we have the application subnet over here, and the route it will go towards the application gateway load balancer endpoints, and from there it will send it to the gateway load balancer and then to security applies, and it will inspect the traffic and send it back to the IGW for the internet. So all the routings are done. Now let's see whether we are getting internet on the server or not. Let's reboot the server once. So we have completed the gateway load balancer configuration, and the application servers are sending a traffic to gateway load balancer, and it is getting inspected by our security appliance. How we can check this? I'll show you the traffic on the security appliance. See, the traffic is coming, landing on the gateway load balancers, security appliance server. This is the IP. You can see all the traffic is getting inspected by the gateway load balancer appliance. So that's the end-to-end configuration of AWS Gateway Load Balancers, endpoint service, Gateway Load Balancer endpoints, and the routing to steer the traffic to the security appliance. In, in the today's video, I focused on Gateway Load Balancer and endpoint architecture. In next video, I will go deep into security appliance configuration, including routing interfaces policies and how the inspections actually happen. Thanks for watching, and I hope this will help you to understand the full architecture.